Alright everyone, I'm happy to say it's finally time to start working on probably the hardest project I've ever tried to accomplish um, so far. Generating power with the water wheel. Now what you see here is kind of a rough idea of what this is going to end up looking like, or at least the work we need to do. So this board needs to be elevated like this, and those cinder blocks need to be leveled, they need to be put, they need to be, they need to be leveled, they need to be built, mortar, put together, all that stuff. We need walls on this side too, keep it out. We need more decking like this, so it's going to go from around over here to over here. So probably like two more 2x8s, or maybe like another 2x8 and like 2x6 or something like that. Anyway, we need decking here. This also needs to go up, but I'll probably do that in a different video. Or maybe I'll put in this one, I don't know yet. That needs to be done. Now, this is an old bike, and what I did is I went at it with the grinder, and you can see here, 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 I cut, the derailleur off, I cut the wires off. Almost everything is cut off this bike except for the parts that we need. So here's what it does. It is flipped over, and you can see these pedals will drive this wheel here. Now, what this wheel does is it acts as a pulley. So there's going to be it's going to be either a V-belt or a lawnmower belt, probably a lawnmower belt, going from here down to the generator. And I'll show you the generator in a second. Now what this does is it fits into here, and there's going to be more stuff to keep it in place eventually, but right now it's just these two 2x4s. It fits in like this. So what's going to happen is this crank arm here is going to spin the pedals, okay? This means I don't need to weld anything, and also this crank arm is eventually going to get hinges on it, so I can take this top half of it and just kind of pull it backwards. That way it doesn't engage these anymore. Now what that does is it acts as kind of a clutch mechanism, so I'm able to turn the power from spinning this, from spinning this around and around, to focusing on spinning the actual wheel around. Whether I want to take the power off, or I want the wheel to be able to spin faster, or spin without a load, anything like that, it's just good to have. Another thing you might have noticed, this is just something that kind of happened by accident, but it's nice. You can see this, it's not on, it's not attached with anything. It just kind of knocks in there with the wood. And I'm going to have electrical clamps clamping that in eventually. But what I'm going to do is the teeth of the electrical clamp, I might try and grind them down or something, and I'll put grease on them. Now the reason for that is this has the power of this, and it's not going fast now, but when it is, if I get my hand here and there's something there, that will hit my hand, and that'll hurt. This thing, and it could also damage the wheel because it has a lot of momentum. Right, once this thing gets spinning real fast, it has a whole bunch of momentum. That can really hurt me and the water wheel if it comes to a sudden stop. And even if I put it here and there's something here, it could, break my arm, who knows what. So that's kind of a nice feature. But it once it gets going, it has enough kind of tension to be able to spin the wheels. Now when it is held down like this, eventually that will wear away, and it's kind of slowly happening. So I do need to put electrical clamps, but they're not going to be on there tightly. So that's just something good to know. Now, this is going in, like I said, and it's going to go down to the motor. Now, before I get to working, let me show you the motor real quick. Alright, so this is the generator I have. I went to the junkyard, and I was able to get this out of an old Jeep. And this is it. It has a ground wire, and these two wires, when it spun, I spun it against a exercise bike to get it, spinning at higher RPMs. And when I measured it with a multimeter, what happened is I got it was 12 to 24 volts of AC power. So what I got to do with this now is I ordered a bridge rectifier, and what that is going to do is it's going to take this AC and it's going to convert it to DC. So 12 volt AC to 12 volt DC is essentially what will happen. So this, what's going to happen is it's going to be way around here somewhere, and this will be here. This will be, you know, plugged in and everything, and it'll be spinning. And what I did is I also ordered a lawnmower belt, and that's going to go from here all the way down here, and that's going to spin this motor at high RPMs. Okay, and that's what this is. This is like a transmission sort of, and when I spin it, it'll spin this faster, and this will spin that motor even faster. Okay, so that's what the point of all this is. So this all needs to be built, needs to be leveled. Eventually, I'm going to put a roof over the whole thing. We also have an old chicken coop, and I'm going to try and get that down here and put a, you know, kind of a makeshift foundation for it. It's probably going to be up here, and that's where I'm going to house all the electronics, all that stuff. So, I can hear the frogs. But, so that needs to be done. So this is part number 1 of the series, and in this video we're just going to focus on building everything, and then the next video will focus on getting it to generate, and we're going to hook up all the circuitry, and then the third and final part, we're going to build the encasings. We're going to set up the lights, fountains, maybe even pumps, you know, whatever I'm going to be powering, we're going to do all that. And, you know, finishing touches. So, that's about it. So we're going to get started. Alright, so first thing I need to do is make a level foundation for this. So how I'm going to do this is I'm moving all these, and I'm going to dig a level foundation and put down a bag of paver base, and that'll make it easy for me to level these bricks. So first thing I'm going to do is I'll actually leave this brick. I just want to mark where I got to dig. That's where this paint will come in handy. So now I know roughly where I need to put everything, so let me get to work digging this out. So what I'm going to do is just start digging this out. I just want a level spot to put the paver base. It's really all I need. Alright, that should be good. Good enough, so I'm going to get the bag and we're going to dump it out. Alright. Dump this. And I'm just going to start trying to level this. Alright, so right here, it's really wet, so I'm going to add just some of the 1.5-inch stone in here, just a little bit, and that's going to hopefully make this a little bit stronger. Alright. All right, so that should be good. So now I'm going to start building this up again. And this paver base gives a good foundation. All right, so now what we're gonna do is we're gonna build up this area here till it's the correct length, and then I'm gonna take this 2x8 and we're gonna start leveling everything out and then making another line at the end there to keep everything level. So yep, I'm gonna do that. All right, so step 2, I put mortar into this rock wall and I finished it out on the front. So now I have this pressure treated 2x4 right here, and I'm going to attach all these boards to the wood. And then over here, there's a 4x4 on the ground, so we're gonna attach that. And we're gonna take this board and we're just gonna attach the feet to either end. And we're gonna set it into the ground with these posts, and then this eventually we're gonna get things to kind of hold it down into the concrete blocks so that it's not kind of up and down, because this wall, I'm not a professional and this wall isn't level. It's kind of bending. Over here obviously needs to be leveled and everything because it's not, but that's fine because it's not secured to the ground either. So I'm going to nail everything in, and then I'm going to wait a bit on the leveling and the securing because I want to get the transmission set up first. All right. All right, everyone, we are almost there. I made this little thing to keep it up. This whole area is leveled. Everything is all set. It's cranking. The only thing is this right here. We're going to do two things. We're going to put an electrical clamp in, and we're going to take this, cut it right around here, and put a hinge on it so I can bend it backwards as like a clutch kind of thing. Also, I didn't end up recording everything here because it was basically just me going up and down to the house. You can see I'm out of breath from running it like, 10 different times to, cut all this wood, get it all the right sizes, get nails, all these tools, all sorts of crap. It was kind of a big thing, and I'm running out of daylight, and I want to get it done today because I've been waiting way too long. I've been way too busy. But this is looking good, so I'm going to put that on. And then we're going to get this belt on and hopefully get somewhere near to being able to spin the alternator by the end of today. So I'll do that all off camera, and I'll update you when this thing is finally working. All right. All right, so I got the transmission all set up, the stick is all down, and I put this in to block some of the splashing water from touching the motor. This is what I have right now, and there's a couple things that I need to do. Number one, this belt here, it's a V-belt, and that probably wasn't the wisest choice, because the thing is you can see it's loose, but if I tighten it, it stops the whole wheel. So that's not ideal. So what I gotta do is a serpentine belt is probably going to be the best bet, because that's gonna be flat. And in addition, I'm kind of having a little like struggle over this motor, because I'm not an electrician. My knowledge for this type of thing is kind of limited, and so I'm currently trying to figure out if this is an AC single-phase motor or an AC three-phase motor or a DC motor. Because if I take my multimeter here, and if I just take these prongs, and while measuring AC, if I take these two, which originally I thought this was the positive, this one here, the red one, and this was the negative, the green one, right? So if I take these, come on, it's hard to do one-handed, but if I stick them together, all right, so if I hook them up with the green on black and red on red, it then gives me a voltage of around 9 volts of AC. Now, for the longest time, I thought this was the final output, so this was an AC motor, and I also thought that this blue wire was a ground. Then I bought this rectifier, and this is a single-phase AC to DC rectifier. Plugged everything in, messed around with it a whole bunch, and I never was able to get DC out of it. So then I was starting to question if I was ever correct about this. So I looked up the actual US code for the red, blue, green, and what I've heard is that green is actually the ground wire, and so it's actually red and blue. So then, if I hook up the red and blue together with these prongs, I then get a much lower AC reading that isn't very stable, right? So I get a lower voltage, but in addition, and this is the weird thing, if I switch it over to DC and I start measuring, I get, well, they're reversed. Oops. There we go. I get in decimal format, or lower for some reason. Oop, hang on. So I get like 1500 volt DC. So now I'm getting DC out of what I thought was an AC motor. The other thing is, I think I talked about this, but this is a generator, not an alternator. And I know these were used to directly charge the batteries, and also they would, you know, the battery would go to them and they would spin and crank the engine. So it could generate and crank, you know, an engine at the same time. So I don't really know. And like I said, I'm not an expert with this. So I have a three-phase rectifier coming in, but I'm starting to, you know, genuinely be wondering if this was actually a DC motor all along. And I think this might be like the wrong form, because I think there's multiple ways of measuring DC. So I gotta look into that, and then maybe I'll get an actual voltage that isn't a lower decimal. But I don't know. I know this video has been a long time in the making, and some of my other videos have been. So hopefully I will be uploading more soon. I have a bit more time off because I've been working, you know, like 7 days a week, you know, to pay for it all. And hopefully I got rid of some jobs, and now I should have more free time to work on this. So in the next video, what I'm gonna do is, I have an old chicken coop. It's been cleaned out and everything, and it's about 8 foot long by 4 foot. I want to put it right there, so we'll get rid of that and we'll put it right there. You can faintly see that yellow line. I marked out where it's going to go. Either that, or I'll put it on stilts, kind of, to be overlooking here, and I'll put like a window in. Either way, that chicken coop is going to house the electronics, because once this comes out, you know, it needs to go into a whole system that's going to have batteries and an inverter and charge controllers and everything like that. So that all needs to be done. In addition, I also want to build up an overhang and a way to kind of shut this area in when it rains. So I want to be able to protect this all from rain. And also I want it to be able to be seen, kind of, right? Because if this is all covered up, it's going to be kind of boring, because, you know, the road's right there, people pass all the time. You know, I like it for people, you know, to be able to see. So yeah, chicken coop's going down here, and we're building that in the next episode. So I'll see you then. Have a good one.